up now. And you could, if you want, you could kind of get started on it, and then next time we'll continue this. I'm going to say a car goes 60 miles at 40 degrees north of west in 3/5 of an hour, and turns around and goes 35 miles at 70 degrees east of south in 5/12 hour. And I'm going to ask several questions on this. This is going to be the two-dimensional version of the other problem we did. Remember in chapter 2, we did a problem like somebody goes to the right and stops and goes to the left. So they go, let's say, 20 miles, and then I give you the time, and then they go to the left, let's say, 50 miles, and I give you the time, and then I ask, what is the average speed in the first stage? What is the average speed in the second stage? What is the average total speed? What is the average velocity in the first stage? What is the average velocity in the second stage? What is the average velocity total? What is the average acceleration in the first stage? So it's going to be, this is going to be similar to that, except you're changing direction here. Okay, it's not simply just right and left. So the first part of the question, I'm going to say, from there, how far and in what direction should the car, from there, how far and in what direction should the car go in order to end up 10 miles at 45 degrees south of east? In other words, from there, how far should the car go so that its final destination is 10 miles at an angle of 45 degrees south of east? So that's the first part. And then part B, I'm going to ask, from the first two paths, for the first two paths, calculate average speed in stage 1, average speed in stage 2, average speed total, average velocity in stage 1, average velocity total, average velocity in stage 2, average velocity total, and then average acceleration in stage 1, average acceleration in stage 2, and average acceleration total. Now we could do a quick one. It's just going to take about a minute. We could do a graphical representation of what's going on, and then next time we'll do the actual. We could do equations. This car is going 60 miles, 40 degrees north of west. So this is west, so 40 degrees, so something like this. So this is vector A. So this is 40 degrees. And then vector C is what? Vector B is the second one. Turns around and goes 35 miles, 70 degrees east of south. So 35 miles is about half the length of this. And how do we draw 70 degrees east of south? So you have to kind of translate the coordinate system here. imagine you have another coordinate system right here. And from there, draw a vector that's 35 miles, 7 degrees east of south. How do we draw 7 degrees east of south? So if this is south, 70 degrees east of that. So 70 degrees this way. Where's that going to take us? Is it going to be like this, or is it going to be like that? Is it going to take us beyond the vector A? So you could use a little geometry here. You could say, well, if this is 40, therefore this is 50, right? Is that 50? 40, 90, 50, right? So that's 50. So if I go 70 degrees east of south, this way, that means I'm passing vector A by 20 degrees. Okay? So it's going to be somewhere like this, something like that. 70 degrees, and then 20 more degrees would be 90, right? So the picture, nice picture, will look like this. Practice doing a nice picture for this. This is a kind of a tough one. So you go a little bit more. This is 70 right here, and you bisect that. You bisect what's left. You see? Because if you go 20 more, that'll be 90. So that'll be vector B, and then how far do we go? 35. So that's about half of this, something like that. Okay, we end up right there. So our goal would be to find the average velocity during that, between stage 1 and stage 2. Average velocity stage 1, average velocity stage 2, average velocity total. And then from there, how far does he have to go so that he ends up 10 miles south of east? So where is that? 10 miles south of east. So if this is east, and this is south, 10 miles south of east. So that's going to be about like there, halfway. So we can call that vector D. So A plus B plus C must equal to D. And we're trying to solve for vector C. So what's vector C going to look like? Basically something that starts there, so something like this. So vector C looks like it's almost going through the origin, okay? So I expect the answer to be something like this. This is a very, very rough answer, okay? I expect the vector C, based on simply this alone, I expect it to be, let me see here. Okay, it's a little shorter than A. So what was A? 60 miles? It's going to be roughly about 50 miles. So we'll test my rough answer on next week, okay, next time. And angle of vector C we expect to be what? It looks similar to the same angle as vector D, right? Maybe a little bit less than 45, because it's coming in a little less steep than 45. So I would say something like 40 degrees, okay? About 40 degrees, and the angle is going to be south of east. So based on simply really quick sketch, that's my answer. And then we'll do the actual math next time. Okay? Good.